Welcome to the Crazy Hat Chemist. So today we're doing another video on bonding. So let's get moving. Bam! Today we're talking about the compression of bond angles. So given the same number of domains, that is regions around the central element, lone pairs of electrons on the central atom compress bond angles, okay, of the bonding domains. So that means lone pairs on the central region compress, that is compress bonding angles of bonding domains. So let's see how that's applied for the most three basic ones here. So this first one here is going to be tetrahedral, and that's on the far left-hand side. Okay, the middle one is trigonal pyramidal. The one on the far right is bent or angular. I'm going to point out a few things here. I got the ball and stick models for each of these, okay? And this first one on the left is AX4, and you can see that in that white and black stick drawing there. It's the A in the center, remember the X on the 4, there's 4 X's around it, and that's tetrahedral. There are no lone pairs on that. Then in the middle one, it's trigonal pyramidal, it's AX3E. So there's a lone pair on that central element. And then in the far right-hand one, which is bent or angular, it's AX2E2, and that has 2 lone pairs on the central element. All 3 of these are sp3 hybridized. That means they all have 4 domains. That's S, P1, P2, P3. They're all sp3 hybridized. Verify that for yourself there. Okay, the number of bonding and non-bonding domains are the following. On the far left-hand side with the tetrahedral with the AX4 structure, there are 4 bonding and no non-bonding, that's lone pairs. On the middle one, which is trigonal pyramidal, there's 3 bonding domains and 1 lone pair, that's non-bonding domain. On the far right-hand one, which is bent or angular, you have 2 bonding domains and 2 non-bonding domains, which are 2 sets of lone pairs of electrons. Okay, so take a look at each one of these structures here. The tetrahedral structure, and that a good example of that would be CH4. There are no lone pairs. The trigonal pyramidal structure, a good example of that would be NH3, which is ammonia. Okay, and then the far right-hand one, which is bent or angular, a great example of that would be water. Okay, on the far left-hand one, which is tetrahedral, there are no lone pairs on that central element. Okay, in the trigonal pyramidal, there is 1 lone pair on the central element, and the bent or angular, there are 2 lone pairs. I've delineated that with the blue highlights there. You should see that the bond angles for these is a compression. So since there are 4 domains around each one of these, so all of these share something in common in that they all have 4 domains, but it's the number of lone pairs on the central element that is critical in compressing the bond angles. Since lone pairs are not localized between 2 elements, that means that they are reaching out there kind of like a big gigantic round balloon, and they can use and occupy lots of space so that they compress the bonding angles. So you should see with the tetrahedral structure, the corners of the tetrahedron spread out using the Vesper geometry would be 109.5 degrees. The next one, which is the trigonal pyramidal structure, has a bond angle that is less than 109.5. And if we were to use ammonia as an example, ammonia's bond angle is 107. So in that 107 region is a very reasonable bond angle for something that's trigonal pyramidal. The one on the far right, which is bent or angular, has less than 109.5. So it's certainly less than the 107, and therefore it's 105. Water's bond angle between the 2 bonding regions is 104.5, and we round it to a whole number as 105. Okay, so compression of bond angles due to lone pairs of electrons on the central element. We don't care about lone pairs on the outside elements, we care about compression of bond angles on the central element. I want you to go look at the molecular geometry the molecular geometry video and take a look at some of those have compression of bond angles, and it was like less than 90. Okay, so some of those structures, like a T-shaped, for example, they have bond angles that have been compressed. or a pyramidal structure, all the like the square pyramidal structure also has compression of bond angles. So take a look at those bond angles that is less than, and you should see that it's less than the typical. And here's a perfect example of that. These are the 3 examples that you most certainly need to know. They are absolutely critical. Every chemistry instructor, teacher will certainly use these as examples and go over these. And except that you will have to imply this to other situations. Okay, anything with lone pairs on the central region, compressed bond angles. All right, that was another Crazy Hat video by the Crazy Hat Chemist, and I got a wizard hat on. Woohoo! Poof! If you like that video, give me a thumbs up, subscribe to my YouTube channel, and I will see you next time. Bye now.